Good evening, everyone. Today we'll discuss how to construct a state function easily. So for that, let me go to the OneNote writing pad. Okay. So first of all, what is a state function? A state function is a function whose value does not depend on the path taken. Suppose I have a coordinate axis. So I'm just defining a 2D space. I have one axis, say x-axis, which increases from the origin, and an y-axis which increases upward from the origin. Origin is defined as a 0 point. Okay. So suppose I have a function that goes from say point A to point B. These are the 2 points. So if I say that the coordinates of the point A is say 1, 1, and the coordinate of the point B is say 10 and 10. So if I say what is the minimum distance between the 2 points, what can I do? I will take the difference between the 2 coordinates, right? So one has to traverse in the x direction 9 unit, and then he has to go up again 9 unit, right? So what is the distance between the point A and B? It is root over 9 square plus 9 square. So this is the minimum distance between the point A and B. So this is root over 2 into 81, so as to say 9 root 2 from the Pythagorean theorem. So this means the mean distance between 2 points, if connected by a straight line, will always be given by the Pythagorean formula. Now let us discuss about a different problem. Again, there are two axes x and y starting from the origin 0, 0, and one person again wants to go from point A to point B, not by a straight line. So now he wants to go by this path, this curvy path. So what happens then? He has to travel a longer path, right? So in real life, I can say this is the path where the person will be exhausted. Why? Because he has to travel more path, right? But if he could take the smallest path between point A and B, this would have been the best path. Okay. So in same way, we can define a state function and a path function, where we can say that if we want to know the change from point A to point B, then if a function exists such that f is, sorry, not a, let us take another function, say x is a function of the initial and final values only. Okay, so it is the function of x and y only, nothing else. So in that case, the function is a state function. So it does not depend upon how the path goes or how the function is carried around. So this is the basic difference between a state function and a path function. Now let us come to our first law of thermodynamics, which states that internal energy can be changed if heat is supplied to a system or work is done upon the system. So internal energy is given by U, heat energy is given by capital Q, and work done is given by capital W. So these are all small amounts. So a small amount is given by small letter d. Now, if you know the second law, the first law is also the conservation of energy law. Now, the second law states that, or you can derive from the second law, the definition of entropy. So, what is the entropy? It is the heat energy absorbed in a reversible process per Kelvin. Okay. So, from there, I can say that dq can be calculated as T into ds. So let us come back to the first law, equation of the first law. du is nothing but TdS plus dw, sorry. Now what is dw? dw is small amount of work that is done upon a system. So if it is only of mechanical of nature, then dw can be given as minus pressure into volume change. We say minus PdV. So the first law becomes du equals to TdS minus PdV, right? So now look at this equation again. From a different point of view. Now u is a function, you are changing the function by very small amount, the change is du, very small amount of internal energy change. How can you change that internal energy? By some experiment. So either you can change the entropy or you can change the volume. So look on the right hand side, small letter d is attached to it, entropy S or volume. So that means you can change internal energy either by, you can say du can be achieved by changing entropy or volume, because on the right hand side you do not see a change in temperature or you do not see a change in pressure. So the equation itself says that if you want to change the internal energy of a system, either you have to change the entropy of the system or the volume of the system. So we can say U is a function of natural variables, entropy and volume, right? Now again, think that there is a closed system, and if you want to change the total energy of the system, you can always add more matter. So this means internal energy is a function of mass also. So that is extensive property. So we can say internal energy is a function of entropy, volume, as well as number of moles present in it. Okay. So if you remember the Euler formula, a small change in the internal energy can be carried out by changing entropy when volume and moles, number of moles are kept constant, or it can be changed by changing the volume while keeping the entropy and the total number of moles constant, or it can be changed by changing the number of moles present in it while keeping the entropy and volume constants. The subscripts always means that they are kept constant during an experiment. So if you see, the first term is associated with ds, and ds is multiplied by a variable del u del s at constant vn. Compare this equation with this equation. Let me say this is equation number 1 and that is equation number 2. So if you compare equation number 1 and 2 with the associated term, you see that ds is associated with t in equation number 1 and ds is associated with del u del s in equation number 2. So they must be equal. So temperature is nothing but del u del s at constant volume and moles. Similarly, sorry, I dropped the second term. dV is associated with del u del v in the second equation. See the first equation, dV is associated with minus p, not just p but minus p. So this means minus p is nothing but del u del v at constant entropy and moles. Now what about the third term, del u del n at constant entropy and volume? We call it the chemical potential. Okay, so del u del n at constant entropy and volume is nothing but the chemical potential. Now obviously in a system there can be multiple constituents present. Let the constituents be I, where I stands for 1, 2, 3, 4, etc. Different types of different numbers of constituents. Say in a solution there is water, salt and sugar. So there are 3 constituents. So this equation 2 that can be written as du equals to T Ts minus P Tv plus del u del n1 into dn1, where S, V and other components 2, 3, 4 are constants. If you want to change the internal energy by changing the second component, it should be del u del n2 into dn2 while keeping other components constant. Okay. So in the same fashion you can add other terms also. So just to make it look more clear or clean, we can say du equals to TdS minus PdV plus summation of del u del ni into dni, whereas we are keeping constants S, V and N, but not the same N as Ni, but Nj, which is not equals to I. Okay. In a simpler form, it can be written as TdS minus PdV plus summation chemical potential mu into dni. Okay, it is clear, right? So this we can say as equation number 3. So first, let us not complicate our lives and just say that we are working with a closed system where the total number of moles do not change. So this means dni equals to 0. There is no change in number of moles. So we are again back with our old formula, question number 1, which says du equals to tds minus pdv, and which means u is a function of entropy and volume naturally. Now the question comes, can you construct a function which is, say, a function of entropy and pressure? Can we construct this? So for that you have to know a little bit of mathematics, but from a simpler point of view, let us say u was originally a function of entropy and volume, from which you want to generate a function, a state function by the way, which is a function of entropy and pressure. So from layman's term we can say that we are replacing volume as a variable by pressure as a variable, right? So how does pressure and volume depend on each other? If you want to increase the pressure, the volume of the system will go down. That means they are inversely proportional, right? And why I am talking about replacing volume by pressure? We know that U is the internal energy, so that is the energy term. So what is the conjugate variable of volume? It is termed as conjugate variable. Conjugate variable of volume is pressure, because if you multiply pressure with volume, it will give you the unit of energy, liter atmosphere. Okay, you can convert it to joule also. The conjugate variable is pressure. So you want the conjugate variable of volume, which is pressure, to replace the original variable volume. Understand? So the new function will be the original function minus the dependencies on the variable. So you want to replace volume. Okay, so this is volume you are subtracting, and you want the conjugate variable pressure, but there is a negative dependency. Negative means if pressure goes up, volume should go down. So the new function will be u minus volume multiplied by minus p. So u plus pv. Okay, so the new function is u plus pv. Now if you remember, what is u plus pv? If you know Joule-Thomson experiment or throttle experiment, this is termed as enthalpy. Enthalpy is our new state function which depends upon natural variables of entropy and pressure, right? Now if I say, can you construct another function from, say, original function u, which was a function of what? S and v. So from u equals to a function of s and v, you want to generate another state function, and this state function should depend upon the conjugate variable of entropy. So what is the conjugate variable of entropy? How to find that? Again, you are dealing with a function which is energy. So how can you get energy using entropy? Think about the units. You can get the energy term if you multiply entropy with temperature, right? You remember what was ds? It was dq by t. What is dq? dq is the heat energy. So that means energy divided by temperature as the unit of entropy. So the conjugate variable of entropy is T, as simple as that. So now you want a function. The new function will be a function of natural variable T and V. How can you construct that? Take the original function minus, you want to get rid of your function s, and you want to replace with its conjugate variable temperature. Now what is the relation between T and S? If you increase temperature, entropy or disorder of the system will also increase. So it is S multiplied by T. No negative sign is there as the before case. So the new function is U plus TS. Do you remember what is U plus TS? Sorry, not plus. U minus TS. So what is the function? U minus Ts, it is the Helmholtz free energy. A equals to U minus Ts. So now, without doing much calculations, you are getting a new function, the Helmholtz free energy, as easily as this. So A is a function of natural variables, temperature and volume. Next is, well, I can go on and on. If U is a function of natural variables S and V, find the form of the function which depends upon T and P, temperature and pressure. So what is the rule? Take the original function minus, get rid of the old variable S, replace it with its conjugate variable T. Again, there is another replacement. So minus original variable V and replace the volume with its conjugate variable minus V. So you will get U minus Ts plus PV. So what is the function that is given by U minus Ts plus PV? What is its common name? Okay, you can club U plus PV together and say it is H. So H minus Ts. Do you remember what is H minus Ts? It is nothing but the Gibbs free energy. So G equals to H minus Ts, or G equals to U minus Ts plus PV, or you can say from here you can club these two and say it is equal to A plus PV. So these are all the same things. So this is how you construct a state function using Legendre transformation. So that is all for today. Thank you for joining.